Hi, everyone. I want you to imagine that you're in the year 2050. You're cruising down the highway and everything looks pretty much the same as it does today. But if you look closely, you'll notice a few differences. You notice that on the road, there is no car noise, no pollution, and those big long haul trucks don't have anything coming out of their exhaust. You see a Whole Foods truck pass by with an advertisement that says its suppliers use zero carbon fertilizer. You look up and see a plane take off, leaving a trail of water vapor. You pull over, and while you're charging your electric vehicle, you read a news article on your phone that says after decades of hard work, humanity was able to limit global warming to 1.5 degrees Celsius, and threatened wildlife is returning to population levels. That's the dream. Now, how do we get there? Snap back to present day, and 2022 marked a new high of global emissions. Now, there are significant challenges in overhauling our entire electricity system, transportation, and industrial sectors. Nobody said it was going to be easy. To paint a picture, I want to walk you through each of their sectors and their major decarbonization challenges. So, electricity. We all know and love renewable energy from wind and solar. The issue is that these energy sources are locationally and temporally constrained, which means they work well when the sun is shining and the wind is blowing where and when you need energy. To get to net zero, the IEA predicts that electricity demand will triple by 2050, with renewables contributing the most to this increase. However, the more renewables that are on the grid, the more long duration storage will be needed to meet peak demand when renewables aren't producing. And what do you do about the regions that aren't optimal for renewables? Second is transportation. Transportation recently passed electricity as the most polluting sector of the economy, accounting for about 8 gigatons of CO2 annually. Transportation has been traditionally reliant on oil products, which accounts for about 90% of the transportation energy sector needs. Moving away from fossil fuels in this sector is a huge undertaking. And then finally, industry. Industry is the second largest source of global CO2 emissions. 3 heavy industries, including chemicals, steels, and cement, which we just heard about, account for nearly 60% of industrial energy consumption and have very few cost competitive substitutes, although we do have researchers working on other substitutes as well. The major challenge here will be producing these materials without emitting CO2. So what if I told you there was one solution to all of these problems and it's all around you? I'm talking about the most abundant element in the universe, which is hydrogen. To understand the potential of hydrogen, consider the following. Imagine that sunlight hitting the ground in Melbourne, Australia in January is able to power a truck in Japan in March. Or that wind off the Gulf Coast could help make fertilizer that grows your food. All of this is possible because hydrogen allows us to harness the power of renewables to use whenever, wherever, and however we like. Now, I'm not here to claim that hydrogen will be used in every single application, but I do believe that hydrogen's place is to help decarbonize sectors that cannot be electrified and powered by renewables. These are dutifully named the hard-to-abate sectors. So hydrogen is the solution to these decarbonization challenges because of its energy carrier properties. You can run it through a fuel cell to make electricity, or you can combust it to turn a turbine. Hydrogen can play a huge role in storing energy from renewables and allowing it to be dispatched whenever and wherever it's needed. Hydrogen provides clean, dispatchable power and can help bridge the gap in energy production in lieu of dirtier fuels like coal or natural gas that will help us bridge that gap when renewables aren't able to produce. In the transportation sector, there will be many technologies that emerge to get to net zero, including electric vehicles and powering vehicles with hydrogen and its derivatives. Some of the most attractive applications of green hydrogen in transportation include off-road vehicles, commercial long-haul transport, and buses. And finally, people are working on uses of hydrogen for high heat and heavy industry and to change the way that steel is produced to use hydrogen instead of coke and coal. So how do we get to this hydrogen-powered economy? Well, first, regulation is needed to kickstart the hydrogen economy. The good news is that last year, the US passed the biggest climate bill in history, and in it, there were significant subsidies for green hydrogen production. Other countries can look to the US as a basis for forming their own subsidies. Cost competitiveness. In order to become widespread, hydrogen will need to be cheaper than all other alternatives. It will take time to bring hydrogen down the learning curve, but we're definitely on the right track. Customer willingness to pay. In the meantime, there will need to be early adopters who are willing to pay a premium for green hydrogen and take a chance on a new technology. And finally, we will need to have the infrastructure in place to store and transport hydrogen. This includes pipelines and maritime transport to get hydrogen from the point of production to the point of consumption. Now, finally, I want to talk about what I'm doing to accelerate the adoption of hydrogen. I'm working at a clean tech venture capital fund, and part of what I do is look at innovative technologies in the hydrogen space. I want to leave you with a few of the most exciting. So electric hydrogen is a startup that makes electrolyzers, and electrolyzers are a technology that uses electricity to split water, H2O, into hydrogen and oxygen. Most hydrogen today is created using fossil fuels in a process called steam methane reforming, and it's very carbon intensive. So electric hydrogen makes zero emission hydrogen using renewable energy and an electrolyzer. And they are leveraging the laws of physics to create an electrolyzer stack that can produce green hydrogen cheaper than traditional dirty methods. Next is Amogy. Amogy is a startup that is working to solve the transportation and storage issues of hydrogen. So because hydrogen is so small, the atoms have a tendency to leak through their containers and embrittle steel. So Amogy is enabling hydrogen to be combined with nitrogen and form ammonia, which is a more stable compound to move around. They have a proprietary technology to crack hydrogen or to crack ammonia back into hydrogen at the point of use. And then finally, ZeroAvia is taking hydrogen to the sky by building a hydrogen-fueled plane to enable zero-emission transport. So it's time for the next industrial revolution. We can harness the power of the wind and sun to build a sustainable society that runs on hydrogen. This is how we end the fossil fuel era. Thank you.